Tomorrow, you have your test on area. I'm going to show you the front of your test so there are absolutely no surprises. This is what the front of your test looks like. Surprise! It looks a whole lot like this chart, right? So you're going to begin your test by on the front filling out the formulas in this chart. Okay? So you need to add the formulas in the chart. Remember you when we started learning this that you don't need to know the rhombus one. So that one I won't ask you. But otherwise you need to know these area and perimeter formulas and be able to fill them out. That'll be the front page of your test.
Do we have to write down both the area and perimeter?
Maybe.
Oh. For circle, is it both? Because I noticed for all the others,
Maybe.
Area.
So, I'm not going to tell you. I told you you need to know this chart. You need to know all of them. You're responsible to know all of the perimeter and area formulas, with exception of the rhombus. Okay? You do not need to know the volume formulas that are on the back side of it yet. We'll begin chapter 12 stuff on Friday, and then we'll start working through those volume formulas. But you do need to know the front side of the chart, all the area and perimeter formulas. When you take your test, you may fill out the front of your chart and then come up and have me grade that and then go on and do the back side. I will not only grade it, but I'll fix it for you so that if you get a formula wrong, when you flip it over and start doing problems, you're working with the right formulas. Because otherwise I'm going to end up having to mark a whole lot of problems wrong. If you have a formula wrong and then you're using the wrong formula, you're going to get all your answers wrong. So you can come bring the chart to me. I will make sure it's all right, and if anything is wrong about it, I will fix it for you so that you have the correct formulas going into the back side. Okay? The back side looks almost exactly like this. Really, I mean, the everything's exactly like the same set of directions, just the problems have different numbers on them, okay? So for each problem, we want to make sure we show our work. If you don't have any work, you don't have any chance of getting partial credit. If there's units, you want to make sure you put units in your answer. And you want to make sure that if it happens to ask you for more than one thing, that you make sure that you give all the things that you're supposed to give. So in light of that, when I do these problems, I tend to mark up the problem as I read through it. And I'll show you how I do that as we go through the review. You don't have to do this, but you might find it to be helpful as well. So for the first question on our review, find the area. So I circle that or underline or do something to make sure that I know that that's what I'm going for here. I want area of a square. I'm a very visual person, so you don't have to draw pictures, but I like to draw a picture of what I'm working with. With a perimeter of 44 centimeters. When I'm reading through, if I see a unit, I circle it, underline it, highlight it, do something to make sure that when I'm done with this problem, I notice that that was there and I need to make sure that's in my answer. Because that's a really sad way to lose points is just by not putting units. But you will. Okay? If you don't put units and you're supposed to have units, you will lose points there. So I want to make sure to do something to kind of red flag myself that I want to make sure those are my answer. So I'm given a perimeter of 44 centimeters. To find the area of a square, an area of a square is base times height or length times width, but for a square, they're special because they're all the same. So it's really just the side squared because all the sides are the same in a square. So if the perimeter is 44 to go all the way around the edges and all of the sides are the same, how big are each of the sides? 11. So if I need 44 all the way around and all four sides are the same, each side must be 11. So our area is then 11 squared, which is 121 unit centimeters squared. It's an S, side squared, not a 5. That's the formula for a square, side squared. For number 2, find the area of a rectangle with a width of 3 and a diagonal of 5. There's no units here, so we don't need to worry about putting units in our answer. Area of a rectangle formula is base times height or length times width or whatever letters we want to use. It doesn't really matter. So I guess since the problem says width, I'll use length and width. But it doesn't really matter, whatever letters you want. I know the width is 3, but 5 is not the length. 5 is the diagonal. So how do I find that missing length side? Pythagorean theorem. So we're going to do 3 squared plus the length squared equals 5 squared. So 9 plus length squared is 25. Subtract out and I get 16 is my length squared, which means the length of the rectangle is 4. Plug that in and I get 12. There are no units in the problem, so I don't need any units in my answer. Caution. One thing I've noticed on some homeworks coming in as I look over them, and then also that I've noticed in the past 8 years of teaching this class, is that when there are not units in the question, students still want to square something. So units are supposed to be like centimeters squared, inches squared, something like that. When there are not units in the problem, students will often square their answer. That is different, right? 12 squared is very different than 12, okay? So we don't want to square our number, we want to square our units, okay? So if there's no units there, then we don't need to worry about it. If there's units, we want it, but don't square the number, we square the units, okay? And if you want to try unit squared, that's fine, but don't square the number. Questions on that one? Next one, find the area of a trapezoid. With bases of 4 and 12 and a height of 7. Area of a trapezoid formula is one that you do need to have memorized. A half of height, base 1, plus base 2. That's probably one that you're less familiar with, so that's probably one you should put some extra effort into studying and making sure that you know. So then if we plug in what we know from the problem, the height is 7, the bases are 4 and 12, and we know everything we need to be able to calculate this. Order of operations says that we need to add the 4 and the 12 first. Is 16, and then we can multiply that all together and get 56. There's no units in the problem, so I don't need them in my answer, but don't square the 56.
We can use a calculator.
You may use a calculator, yep. Number 4 is about a rhombus, and we're not working with rhombi, so we will just skip over that
So
one.
it won't even be on the head.
Nope.
What's the next one?
Number 5, find the area of a right triangle with legs of 21 meters and 12 meters. So I have a unit here. And make sure I take a note of that to make sure I put that unit into my answer. What are the legs of a right triangle?
The base and the height.
The base and the height. They're the not hypotenuse. Okay? So a right triangle has 2 legs and it has a hypotenuse. The legs are not the hypotenuse. So it turns out then that they're the base and the height. We don't know which one is which, but it doesn't really matter. One of them is 12 and one of them is 21. The area of a triangle formula is that area is 1/2 base times height. The legs are the base and height. So I get 1/2 of 21 times 12. It doesn't matter which one is which because 21 times 12 is the same thing as 12 times 21. So it doesn't matter which one we call the base and which one we call the height.
What about when we like cut a triangle in half to like find the up and down?
To find the height, that's if we don't actually know the height. Here we know the height since we have a perpendicular, since it's a right triangle. If it wasn't a right triangle, then we would need to find height or be told height. Multiplied out, we get 126. There was a unit of meters, so we need meters squared on our answer. Questions on any of these before I scroll to the last group of problems? Alright, so our next question is about a circle. We want to find the area of a circle with a diameter of 16. And there's a unit on that, inches, so I'm going to make sure I include that unit in my answer. Our area formula for a circle is pi r squared. So we need a radius. We're given a diameter. So what is our radius going to be?
8.
8. If it's 16 all the way across, it's 8 halfway across. So we're going to be working with the radius of 8. So pi 8 squared. As we did in the homework, we're just going to let the pi's tag along. So I'm going to square the 8, make it 64. And then just let the pi tag along. Unit, inches squared. Yes.
Are there going to be any perimeter questions on those?
There could be
Could move up.
perimeter questions. We had perimeter involved in the first example. In example 1, perimeter was involved in that one. But you do need to know both area and perimeter formulas. Number 7, we want to find the area, again, of a circle, and we're given a circumference of 14 pi. So circumference is equal to 14 pi. We're asked to find the area. Area of a circle is pi r squared, but we aren't told what the r is. So we can't jump right to finding what we really want to find with our area because we don't know radius. So that means we need to find radius first, even though it didn't really ask us to. We're going to use that circumference to find the radius because circumference is 2 pi r. So how do I solve that to find out what r is? Divide by 2 pi. That will cancel out to just leave r all alone. Pi's cancel and 14 divided by 2 is 7. So I have a radius of 7, which I can then take and find my area.
Please excuse this interruption. With the students involved in chapel worship this morning, please go to the cafeteria.
I get 49 pi centimeters squared.
Yeah, for the finding the radius,
Mm-hmm.
you've got the circumference. Can you just divide by 2 and
Divide by 2 pi.
yeah, and get rid of it?
You could just divide by pi though, right?
You can't just divide by pi because you have to get rid of the 2 also.
But then can't you divide it by 7? Oh.
Yeah, I mean you can do it all at once or you can do them separately, but yeah, you have to divide by both. Next one, find the area of a sector of a circle with a radius of 5 and a central angle of 75. So our area of a sector formula is x over 360 pi r squared. Pi r squared is an area of a whole circle, and when we want to break it down to just give a slice of that circle, we do the x over 360. 360 because that's how big the whole circle is, X is just taking a slice of the circle. And that formula is probably one you're not as familiar and comfortable with, so maybe a little bit of extra effort on that one more than probably a rectangle or a triangle. So then we plug in what we know. Our angle is 75. And our radius is 5. Then you can plug this in on the calculator and do 75 divided by 360 times 5 squared. Just don't press the pi, but type in all the other numbers in the question. I don't know why I picked these numbers when I wrote this example, because it does not turn out to be anything nice. So I'll just round it to 5.2, and then the pi tags along. There is no unit in this question, and pi is not a unit. So another common thing that I see is students will write 5.2 pi squared. Okay? The pi is not being squared at any point in the formula. The radius is squared. Okay? We squared the 5, but we didn't square the pi, and it's not a unit, so we don't want to do like pi squared like we would do centimeters squared. Okay? It's just a plain pi. Last one, we want to find the arc length in a circle. So we're looking for like the pizza crust along the edge of the circle here, with a central angle of 144 and an area of 40 pi. We're asked to find length, so our arc length formula is x over 360 times 2 pi r. 2 pi r would be the full circumference. X over 360 gives us just a piece of that circumference. So for this, I need to know my angle. That's 144. I know that. I also need to know my radius, and I don't know that. So that is why they gave us the area. We're going to use the area with the area formula to find the radius. So area, using the same formula as the previous problem, is x over 360. In this case, our angle is 144, pi r squared, and we don't know r. First thing I can do to simplify out this problem is divide by pi. Then to get rid of that 144 over 360, I'm going to multiply by the reciprocal of it, 360 over 144, because that will cancel both parts of that fraction on that side. But since this is an equation, whatever I do to one side, I have to do to both sides. So I'm going to multiply that on my calculator. 360 divided by 144 times 40, and I can type that all into my calculator. You are allowed to use calculators. So we'll end up then, this turns out nicely to be 100 is equal to r squared. So if 100 is our radius squared, then our radius is 10. And now we can plug in to our arc length formula to find what we really wanted to know. You can plug that all in the calculator. 144 divided by 360 times 2, skip the pi, times 10. And that gives 8. And that pi just tags along.
I did it a different way, and I want to know if it's a fluke. For the area, I knew that 144 over 360 was 0.4, and then I just knew that because it needed to end up being 40, it would have been, it would have to be.
Yeah, you did it. You just reduced the fraction, and I didn't bother reducing, but it's the same thing.
Why did we flip the 360 over 144?
To cancel it, the way you cancel a fraction is by multiplying by the reciprocal of it, because then you'll cancel out each top and bottom and just be left with 1.
So you made a Quizlet for this? What was the Quizlet name?
I didn't create a Quizlet, so I don't know if somebody else has. I created a Study Blue, but that was before you guys were all into like Quizlet. Study Blue is pretty much the same thing. It's just a different website. But I'm sure there is a Quizlet out there for this.
Check if it's right.
Alright.